Hi Brian, and greetings from New Jersey. Okay, since you've been away, we've been working on graphing polynomial functions. So polynomial functions look like something like that. You have x cubed, x squared, x, possibly x to the fourth power, x to the fifth, and that's all equal to the function. So their graphs kind of look like curves that kind of wind around and bend and go from here to there. They either start down and end up, or start up and end up, or start down and end down. And it's possible, if we have the factored form of the function, to draw a rough sketch of the function without even using a table of values. So here's how it works. So if we have a function factored like this one here, then these numbers, if you reverse the signs, you get the points on the x-axis where the curve intersects it. And that's because if at any of these points y is 0, so if you put in any of those values for x, you're going to get a value of 0 for y, or the value of the function. So right off the bat, you already know a couple things about what the function is going to look like, namely where it's going to cross the x-axis or the x-intercepts. Now there's a few other things you can determine just by looking at the factored form of the function, and the other thing is the end behavior of the function. And when we say end behavior, it means what happens to the graph or the curve in the end regions of the coordinate plane, meaning as you get farther to the left and farther to the right, what happens to the curve. So in the first one example here, we would say that it has up end behavior. That's because the curve ends up going up on the left and on the right as it approaches infinity and negative infinity. The second one, this would be down, down, because the graph keeps going down on both sides. This one would be up, down. This one would be down, up. So I think it's pretty obvious, hopefully, what I mean by that. But once you know that for a function, you can use a table to figure out. Let me take that back. The end behavior, before I get to the table, is determined by if the leading coefficient of the function is either positive or negative, and whether the degree of the function is even or odd. And the degree of the function is the sum of the exponents of all the terms that have the variables. All right, so for example, these functions right here, this would be positive because 4 is a positive number, meaning the leading coefficient. And then I would add up the exponents, and I would get 2, 1, and 3. That adds up to 6, which is an even number. So that means this function is positive even. And if I go to my table, then I go even, positive. That means it's going to be up, up. All right, the next one is going to be negative because of the negative sign on the leading coefficient. And if I add up the exponents of the terms with variables, I get 1 plus 2 is 3, and 3 is 6. 6 is an even number, so that would be negative even. So it would be down, down. The next, actually, why don't I do, we'll make that one be positive. The next one, this one right here, is also negative even. This one would be positive odd. This one would be negative even. because 4 plus 2 is 8. And this one is going to be negative odd, because 2 plus 3 is 5 plus 10 is 15. Now, a couple things when you're trying to add up the exponents. If you have an exponent that has no plus or minus after it, that also counts as a factor with an exponent. I mean a variable with no plus or minus sign after it. So if I had x plus 3 times x squared times x minus 6, I would put ones in for those exponents, and then I would count the 2 as well when I was adding up the exponents. So I would get 1 plus 2 plus 1 is 4. So that would be even. Okay, there's one last thing you need. After you know the end behavior, you know where the x-intercepts are, you need to know what happens to the graph at each x-intercept. So if you look at these 3 points here, you'll notice that in the first two, the curve goes straight through the point when it crosses the x-axis. In the third point, instead of going straight through down to the other side, does a total U-turn and continues on straight up. So the first two points come from factors that have odd exponents, and the second point, or the third point here, comes from a factor that has an even exponent. Likewise, if we look at this graph here, this first point comes from a factor in the function that has an odd exponent, and this one comes from a factor that has an even exponent. So if we had to write the equation based on looking at this, it would have to be, let's see, the x plus 1 would be that point. And remember, you would reverse the direction of the number when you're going from the x-coordinate to the factor that would be associated with it. And then the other point would be x minus 1. So we would know that this would have to be either 2, 4, 6, or 8. This exponent would have to be an odd number, either 1, 3, 5, 7, and so on. Okay, so this all comes together and allows you to sketch a graph just by looking at the function. Now this won't tell you how high or low these little peaks are that occur off the x-axis and somewhere in between the x-intercepts. You need to use a table of values to figure out how high or low those points will be. However, this will tell you, basically, give you a pretty good rough sketch of the graph. So let's do a few problems. And this first one, the degree of the function is going to be 2 plus 1 is 3, 3 and 3 is 6, 6 and 4 is 10. That's an even number. The sign of the leading coefficient is negative. So negative even, if you look in that table, is down, down. Okay, so now what are the x-intercepts? Well, you go through each factor, and so I have a negative 4, a negative 2, and for each factor I reverse the direction of the sign that's in front of it. 1 and 4. And now it says circle the turning point x-intercepts. Those are the ones where the graph does a U-turn when it hits them. And those are the ones that come from factors that have even exponents. So if you look, x plus 4 has an even exponent. What's the intercept associated with that? Negative 4. X minus 4 also has an even exponent, and it has its x-intercept is 4. Alright, so now I have my little chart filled in, and I'm going to go ahead and ready to graph. So the first thing I do is I put in the x-intercepts, so this, and I circle the ones that I circled here. So that's negative 4, negative 2, 1, and 4. All right, now I'm ready to graph. Okay, so graphing, when you're ready to graph, you're essentially connecting the dots from left to right. And then as you're going along, you look to see if you should go straight through the x-intercept or do a U-turn when you reach it. Either way, once you leave one x-intercept, you head immediately to the next one, going from left to right. Okay, so since this graph starts down, I'm going to come up from down, and then I have a circled intercept, so I turn around. I go to the next one. This one is not circled, so I go straight through. Go to the next one, not circled, so I go straight through. Go to the next one, it is circled. Then continue, turn around, and continue on. And the graph ended up down, and that is what it was supposed to do. So that's usually a pretty good sign that you probably graphed it right. All right, this next one is, let's see, so what is the degree of the function? It would be 3 plus 1 plus 4 plus 2. That is 6 and 4, or 10. 10 is an even number. The sign is positive of the leading coefficient. That means even positive is up and up. My x-intercepts are -5, 0. When you have an x all by itself as a factor, the corresponding x-intercept is 0, 1, and 5. Now, which one of those come from factors with even exponents? The 1 and the 5 do. So now I'm going to go graph those points. And I'm going to circle the ones that need circled. And let's see, the graph starts up and it ends up. So if I start graphing it, I need to come down from the up position. I head to the first point. Oh, I go through it because it's not circled. I head to the next point. I go through it because it's not circled. I head to the next point. I turn around because it is circled. I head to the next point. I turn around because it is circled, and I end in the up position, which is what I'm supposed to do. All right, the degree of the next function, let's see, it's a 1, and 2 is 3, 3 and 2 is 5. It's an odd number. Negative is the sign of the leading coefficient, and that means odd. Negative means it starts up and ends down. My x-intercepts are -6, -3, and 4. And -3 and 4 have come from factors that have even exponents, so I'm going to circle those. So now I go and graph my points. And I'm going to start up and end down. So I'm going to come down from up. I'm going to come to the first intercept, go straight through, go to the next one, turn around because it's circled, next one, turn around because it's circled, and end up in the down position, which is what I'm supposed to do. All right, so then this last one is, let's see, the degree of the function is 2. It's even, and there's a positive leading coefficient. So that's going to go up and up. The x-intercept, remember when I said you have an x value all by itself without any plus or minus after it, would be 0. Let's see, does that come from a factor with an even exponent? Yes, 2 is an even exponent. So I'm going to graph my x-intercept, draw a circle around it, and now I start up. I come down from the left, oh, I turn around because it's circled, and I go back up. And that is it. All right. By the way, this is just a regular old parabola, but a parabola is a polynomial function. And so you can graph it using the same technique that you use to graph polynomial functions. Okay, I hope this was helpful. I have to say, this is quite exciting to actually have someone in a foreign land watching my screencasts, and I can't wait to tell my supervisor. So I'm hoping that when you come back to New Jersey, this would have been really useful to you so that you can be exempt from the final exam, which all indications are you will be. So I hope your grandfather gets better and that your family is doing okay, and hope to see you very soon. Cheers.